Hello and welcome to the Friday, April 13th edition of TGIK. This week we're going to be talking about the cluster API and the Kubecorn Kubernetes deployment tool that myself and a few other people have been working on over the past year or so. We had some crazy technical difficulties coming to life this morning with the YouTube API buffering a little too heavily and the event being taken away from us and having to recreate the event. So what we did is we got everybody together and we jumped on a Zoom call and still was able to get the TGIK up and running. So that's going to be starting now. Hey everybody, thanks for joining. We are recording the call and we'll give people a minute or two and then we're going to give a quick update on what's been going on my end and then we'll get into Kubecorn and the cluster API. Also, friendly reminder, if folks could just mute their microphones and turn their video off to save on bandwidth, that would be helpful. So give me like 3 minutes to get OBS out of the way, and then I'm going to give an update on what's been going on here. And I will start sharing my screen. I definitely think we're going to be pushing the boundaries of Zoom today, but that's totally cool. Like, this is kind of an interesting experiment anyway. All right, so let's get this, and let's see how I want to do this. Let's see, I can share that desktop. I can get a terminal down here, and I can get this down here, and I can get my TGIK documentation. Sweet. Let's go ahead and get started. So the first thing I wanted to bring up that I had brought up, I think I've done this thing twice now, but we'll go ahead and start, is what happened with the YouTube API. So when my OBS stream, I think what was happening was because of the bad internet weather here at the office, the OBS stream was dropping in and out. And YouTube detected that as like an in transmission and went ahead and like polished off the TGIK live stream. So I think it detected that as, you know, the stream's over, and then we went and published it, and it's kind of like this like one and done thing. So once it got published, there was no way of going back and re-editing it moving forward. So created a second event and was able to get the YouTube API to recognize that and to start streaming. But then because of the buffering internet here, it looks like we were just having a hard time anyway. So now we're going to be testing the limits of Zoom scalability and having 50+ people on the call. And afterwards, I'm going to go through and I will doctor this whole thing up a bit and maybe even give a quick precursor and get this back into the Heptio TGIK YouTube channel. So it'll still fit into the normal playlist of things, but just be in a different format. So hi, welcome everybody. So it looks like we have a ton of people here, and usually we get like a stream of comments, but let's see if I can't pull up chat really quick. How do I do this? And see a list of people who are here. Looks like we have, oh my gosh, there's so many people here. We have Jerry, we have Don Chad, we have Micah, it looks like Craig, Fabrizio, Gabrielle, Rory, Carlton, Noah, Luke, Donald, a lot of familiar faces here. Justin Caslin from here in Seattle, Tim St. Clair, Marco, good to see you. Aaron, great to see you as well. And thanks for joining everybody. So usually the way that Joe does these is he has a list of stuff this week in Kubernetes. My list is about 4 or 5 things long, and we're gonna start off with probably the most exciting thing that happened to me this week at the office, which was this Reddit Ask Me Anything. And I've already talked about this twice, so I'm like actually feel like I'm getting pretty good at giving the spiel on this Reddit AMA. But it was set up by George and some of the other Contribex folks, and they got like myself and Tim and Solly and Clayton and Brendan and Ilya, Ihor, Adnan, and Matt Farina all together, and we did this AMA over the course of a couple hours on Tuesday morning. There's some really great questions in here. You see stuff on like what is your favorite way of learning the Kubernetes code base? Where do you think is the future of Kubernetes? If you were to try to learn a new part of the code, what is your like preferred method of doing things? We even had a question here, what advice would you have for the Docker Swarm team? So this is cool because it wasn't so much just technical resources of what's going on in Kubernetes. It was actually like, what are your thoughts and feelings and opinions on some of these like somewhat controversial questions about Kubernetes. So this was a lot of fun to hang out at the office and get to talk shop about Kubernetes. One of the things I wanted to pull up on this page though is we mentioned kops a few times and we mentioned Kubeadm a few times. And I don't know if we're gonna be able to get it here because we have over 300 different comments. So there's definitely a lot of material here if you want to go through and read it. But yeah, we had a good question about kops and the future of kops and Kubeadm. And I think this is really relevant stuff to understand as we start looking at Kubicorn and the cluster API and kind of where Kubicorn came from, where the cluster API came from, what's the future of infrastructure, what's happening with kops, what's going on with Kubeadm. So hopefully today I can kind of like tie a lot of this stuff together. So that was the Reddit Ask Me Anything. The other thing that I wanted to pull up that I thought was pretty slick was Dan Cohn from the CNCF had gave a presentation on this new interactive landscape on the community call earlier this week. So this is pretty cool because you can come in and you can actually drill down and start to filter on like different categories of cloud native software and like see like, oh, I want to see what type of CI/CD stuff is out there. And you can go and, oh, here's Brigade from Microsoft. And like, we can go and look into it. And this is a really good resource because it kind of acts as like the master list of cloud native software. But I think it also does sort of like play as this like starting point for starting to learn what's out there. And even for me, like, I'm pretty sure Kubicorn made it in here at some point because I adopted the CNCF code of conduct and, opened up a pull request to get it added to the landscape. So to me, this is kind of inspiring to see all of these open source projects coming together and sort of being managed by this open source Cloud Native Computing Foundation. So every time I come here and I see a new project in my mind, it's always like, hey, there's somebody out there who's like their project, they made it and they're getting the support they need. So that's pretty rad. The next thing we have is I wanted to do a quick shout out to the release team. We just released Kubernetes version 1.10.1. I have the changelog here and I always like to go through and kind of read like what's going on in the changelog because that kind of gives me an idea of the types of bugs folks are going in and seeing. So the first one that actually, like, I think I remember when this thing happened and coming across the same issue was when you were doing a kubectl run and trying to do an attach, you would get a panic. So just like seeing these bugs getting fixed is always really exciting. It looks like there's been some other changes to kubectl and we've done, looks like some work over Unix sockets and Node OS distribution. Gosh, I'm losing track of what all is going on in upstream. There's always so much. So big shout out to those folks. The next one we have here is, this again was brought up in the community meeting this week, but I wanted to call it out. We have Meet Our Contributors, which is another thing that KontribX is doing. I was on it a couple weeks ago, and I think a couple other contributors have been on it as well. It's more of like a formalized Reddit Ask Me Anything. It was a pretty cool experience. We jumped on a Zoom call and it was kind of like, what can you answer about Kubernetes? What is your favorite ways of learning the code base? What is your favorite ways of developing? What does your development setup look like? So this was a really exciting thing to be on. And then the fact that it happens and it's scheduled is even more rad. So if anybody is interested in being on this or even attending, you can join SIG KontribX, and there's a Meet Our Contributors Slack room as well. And again, like always, I'll put links to all this stuff in the YouTube channel after I go back and re-edit everything. The next thing I wanted to bring up is we're doing a diversity panel at Kubecon this year, which is rad because we're actually going to talk about how we're going to bring diversity into Kubernetes, like into the code base concretely. So it's going to be an action item driven like program. It's going to be a panel that I will be on. as well as Erica from Red Hat, and will be hosted by Paris. And the whole point here is to come up with tangible action items for actually getting people into the Kubernetes code base and contributing. So if you think you might be diverse, you probably are. In fact, I'm pretty sure everybody has something about them that introduces diversity to the Kubernetes project, and you're interested to get involved and you're going to be in Copenhagen, feel free to come by, check it out, and we will do what we can to help get you contributing to Kubernetes as quickly as possible. Okay, so without further ado, let's look at Kubicorn. So kubicorn.io, it's a GitHub pages, and it kind of gives you like a rundown of what Kubicorn is. But I think it's probably important to kind of tell the story of where it came from and why I started writing it anyway. When I first got into Kubernetes, I started contributing to kops, and the infrastructure layer was like something I had always kind of worked a lot on. I used to contribute to Terraform and used to like spend most of my waking hours working with Terraform and automating infrastructure provisioning. And once I discovered there was a tool that was specific to Kubernetes, of course, I fell in love with it. As kops began to evolve, we began to like really learn these primitives in Kubernetes kind of the hard way. The big thing was like this whole concept of declarative infrastructure. Like I still remember when we first started versioning the API in kops and starting to say we can have different ways of declaring the same infrastructure. So as kops began to evolve, I found it harder and harder to write a cloud implementation, and I felt like the code base was kind of pulling us further and further away from what we were actually doing, which was provisioning infrastructure. Again, this was like sort of my opinion, and I have strong opinions about how I think Go should be written. So one weekend, kind of on a whim, I was out of town and I started writing this project in a private repo called Kubecorn. It was Go for Con last year. I open sourced it and it's sort of taken off. It's now got like, I think 1,000, I want to say, GitHub stars, which means 1,000 people have come here and actually said, hey, I think this is a cool project. And we have some really fantastic contributors. Like, I want to give a huge shout out to Marco, who is pretty much the person holding the project together. He's in the Slack channel almost every day. I think at least once or twice a week. I usually wake up to a Slack message from Marco asking me a question about some pull request or wondering if we can get a feature in. So big shout out to him. My Digital Life has done a ton of work for us, especially in the early days. Ellen Corbs from Brazil, she did the whole kubicorn.io GitHub pages website that you see here. So big thank you to her for that. And then we've got other people who have come in and contributed to everything from signal handlers all the way down to infrastructure provisioning tweaks, all the way up to just writing like wrapper packages for tools like SSH or SCP. So big thanks to everybody who has contributed to the project. And if you are interested in contributing to the project, if you don't know already, I pretty much accept every pull request as long as it's somewhat reasonable. Right now, Kubicorn is in a position that is pretty handy, which is we don't really have a release. So we have this unstable alpha release I put together on March 6th, where the code base was in a pretty stable place. It worked for most cloud providers for getting Kubernetes up and running. And I wanted to be able to come back here if anybody really truly wanted to vendor the code and know that this is not going to change over time. I wanted to call it unstable because this is not a release that myself or the Kubicorn maintainers have agreed to necessarily support over time. Which brings me to my next point, which is when are we going to release the first stable version of Kubicorn? So my goal is to do that at Kubecon in a couple weeks. I think it's about a month away. If we can't do it beforehand, I would actually like to do it at the conference and have our first 1.0. I think the only real big changes we're waiting for in the first release here is the cluster API stuff that we're going to get into a little bit later when we start looking at my implementation into Kubicorn and how I've done it. But we're going to spend a few minutes talking about what the cluster API is before that anyway. So let's actually take Kubicorn for a test drive and see how it works and familiarize ourselves with some of the vernacular behind it so that as we start to explain the cluster API, we can talk about how these various parts of Kubecorn are going to play into it. Okay, so I have this branch I created earlier today. It's called More Hacking for TGIK, and it's got a few changes in it that's going to help us when we get to working on our controller a little bit later on. We can compile Kubecorn by doing make all, and this is going to compile the binary, and then it's actually going to drop it off in gopath/ben, which is already in my path, so I should get it in my path right after running this. The binary takes probably 7 to 10 seconds to install, depending, or to compile, depending on what else you have going on. A lot of the length from that came from vendoring a lot of the Kubernetes packages, which we're doing more and more of as we're adopting the cluster API. Okay, so that compiled. So we can now run Kubecorn on the command line, and we should get, just like with most command line tools, we should get like a list of everything we can do. You'll notice it's also rainbow, and if you want to export Kubecorn true color equal to 1 and run Kubecorn, you will get a rainbow terminal using lol gopher, which Joe mentioned this, I think last week or the week before. It's a package that him and I worked on that basically allows you to take the lolcat Ruby library and run that in Go. And you can do export Kubecorn true color equal to 0, and you can run it again and you're not going to get it. Oh, why do you get it? I don't know why that's not working. Anyway, the commands here are adopt, apply, completion, CRD, create, delete, deploy controller, edit, explain, get config, and there's help, image list, and prompt inversion. Most of these are kind of self-explanatory, but I would say the two that, or probably 3 that you're going to use most is going to be apply, create, and delete. So the way Kubecorn works is it's very similar to anybody who's used kops, is it declares Kubernetes infrastructure somewhere. And that's what the whole create step does, is it creates just like a small bit of usually YAML that declares what we want our infrastructure to look like. And then we can do apply, and then it'll actually go and attempt to reconcile the declaration. This is, like I said, how kops works, and we can see a really quick example here. If I was to do Kubecorn create TGIK, we'll call this EX1 for example 1, and we'll say profile equals DO for DigitalOcean. So by default, Kubecorn will write to your local file system, but you can also stick this in Git, you can also use JSON, and you can also bring whatever implementation you want to the state package. So what that would look like would be, if we go back to, actually I can just pull up the source code here. If we go to our package directory, we don't want controller, we want Kubecorn here. We can go in and see, we have a package called state, and in the state package we have this interface.go, and as long as you implement this interface, you can actually use whatever state store you wanted to store your cluster declaration in. So right now we have the CRD, which is just recently added, and that is actually the cluster API CRD. We have FS, which is file system. We have Git, which uses the Git protocol. JSON FS just basically does the same thing as regular FS, except for instead of using YAML, it uses JSON. And we have S3, which uses Amazon's S3. So you can come in and you can see people have come in and implemented the interface. We have exist, we have write, we have read, and it's basically just like wrapping a file system. So anything that you can remotely treat as a file system, you could implement in Kubecorn as a state store. So going back here, like I said, we first wrote this YAML file using the FS state store. We can now take a look and actually see what this looks like. So here we declare a cluster API, and we have a control plane, and we have machine sets. And if you notice, in each one of these larger objects, we have this provider config declaration here. Now, this is probably the most hackiest thing I've ever done in my life. But in order to adopt a new API, all I did was I munged the old API that Kubecorn was originally built on into JSON for this new API. And we took that JSON and we saved it in the provider config. So now we're using all of the new cluster API objects, but we still have all of our old data and can be marshaled back onto the original structs so that we can still use the old API. The game plan for the project moving forward is that we would actually take definitions out of this JSON blob and start to pull them up into this higher level definition that is defined in open source called cluster API. And again, we're going to go through that a little bit more later. We define the control plane, which is this top one here called cluster API, and we have machine sets, which is this bottom one here. A machine set has a little bit more of definition to it because we go as granular as defining network rules for each of the bits of infrastructure, as well as bootstrapping scripts, which we're going to look at here in a second. So here we have another provider config and another large bit of JSON. And real quick, before I actually look at the bootstrap scripts, I'm going to see if I can't pull up chat to see if people are saying anything. Let's see, how do I do this? So I have manage participants, I have remote control. How do I get into chat? Okay, well, I can't get into chat. So if anybody needs to jump in and ask questions, maybe I can do a stop share. Let's see. There's chat. Okay, now how do I pop out? Bam, this is what we want here. And screen share. And we'll go back here. Okay, rad. Now I can see chat. So I apologize if I've missed any major questions here. I'm going to take a second and just read back through. Okay, looks like we're good. Yay for rainbows. I want a Kubecorn t-shirt. Love the gopher and the unicorn. Still waiting for my Kubecorn shirt. Okay, rad. So as I mentioned, we're taking the traditional or legacy Kubecorn API, munging it into provider config, and now we get all the bells and whistles of the cluster API machine sets and cluster API definition sort of for free, and we can still pull all of the original data back out of the provider config if needed. So let's take a look at these bootstrap scripts. So these used to be in the Kubecorn/Kubecorn repository, and we've now moved them out to their own repo, and we use a Git submodule, which I've talked to a few people who said that there's never a good reason to use a Git submodule. I disagree. I think this is a good time to use one. And the use case here is we have all of the bootstrap scripts that help bring up various parts of a Kubernetes cluster. I think I wrote 2 of these shell scripts, and most of the shell scripts have been written by other people in the community. So like, huge shout out to everybody who's gone through and actually hacked on this bash. I know it's hard because you have to SSH into a server and then run the bash and then hope it works. And anytime you're sort of dealing with cloud init, it's kind of a pain and kind of a lengthy process. So if you don't have a good bash script for bringing up Kubernetes using Kubeadm, these are great resources and great places to start. So the first one we should look at is our Kubernetes Ubuntu master for Amazon. You can see we've defined a Kubernetes version. We go through and we install our dependencies. We create our cloud provider configuration. We actually define a few variables here that we are getting either from the EC2 metadata tool, or we actually cat the cluster.json, which is the same as that YAML we just looked at, to disk on all new virtual machines we create. And we can pipe that to JQ and get various values out of this API that we're looking at here and use them in bash here. So this is where we would get our Kubeadm token, and the port that we would like the Kubernetes API server to listen on. Here we have our kubeadm config.yaml, which if you know how kubeadm works, you can provide a configuration file for it, and then it'll take that configuration file and it'll generate all your static manifests for you. We do a reset, so the thing is idempotent, so you can rerun this script whenever you want. And then we do an init, and we just pass in our configuration file. We just wrote to disk that has all of these variables interpolated in it. We then apply Calico version 1.6 so that we can get some CNI goodness, and we install the storage class for AWS so that the cloud provider can make sense of any underlying storage concerns that we need to have. We then take our kubeconfig and we copy the default kubeadm admin.conf to home Ubuntu kubeconfig so that we can pull it out of this home directory later via SCP. So that's how we bring up Kubernetes on one of these virtual machines. So without further ado, let's go ahead and let's spin up a Kubernetes cluster in Amazon. Let's see what bits of infrastructure we get, and let's go and jump on each one of the servers and actually go and look at these bash scripts and actually see the logs and kind of tie all this together. I feel like this is one of the parts of Kubecorn or any provisionment tool that users are kind of abstracted away from, and I want to show people that it's pretty simple, it's pretty easy, and if something does go wrong, it's really not that big of a deal to go and debug. So we just created a cluster we called Kubecorn create TGIK. We're going to create another one in Amazon. So we will call this one TGIK EX2. We'll do profile Amazon. And here we can do Kubecorn apply TGIK.ex2. And before I do that, I'll just comment this out. I wanted to mention this feature that we coded in that I think a lot of people, especially anybody who's trying to automate Kubecorn, would find useful, which is if I did a Kubecorn create again, and we called this one TGIK example 3, I can actually use this --set command, and we found a Go library that allows you to use basically the same syntax that I think Helm and a few other command line tools use, to where you can come in and you can actually say, I want a --set SSH dot, public key, and then you can come in and you can maybe I want to do some other public key, like, Nova's key or whatever. And that's actually going to yell at me because SSH is not a field of the struct type. Let's see what we have here. Let's find one that works. TGIK, example 2, cluster.yaml. Let's do, we'll do this one, spec cluster network DNS domain. Oh, that set syntax is legit. Thanks, Ryan. So we're going to do spec cluster network DNS domain for our example. So you can do set, what did I say, spec. I just said it, didn't I? Cluster network DNS domain. Cluster network dot DNS domain. We'll call it nova.com. Spec is not a field of the struct type. Does it need to be capitalized? Interesting. I know this was working, but when we switched over to the new API, maybe cluster API.spec. Let's see what Marco says. I think that's right, Marco. I think before it assumed you were always in that top level definition. Cluster API. Let's see, what do we have here? Cluster API.spec. We can actually go and look at the code and see what's going on if we want. Either way, I feel like that's a feature we can look at afterwards. So if anybody wants to open up an issue on that one, we can take a look and see why this is not working. Spec lowercase, case sensitive. Let's try. So here, cluster API. I think, because right here, it's all capital cluster API. Oh, you know what it is? I know what it is. So what it's doing, I remember I coded this in and I merged it in. I remember doing this now. So let's pull up the Kubicorn code base and I'll show you guys what's going on. So here in command, which is where all of our commands are, we have create. And if we scroll down, where is it at? Provider config right here. Here's the package we're using, swalker. So it's everything in the provider config. So it's actually not going to edit the YAML. It's going to edit everything that we've munged into the provider config. So what we could do is we need to pull a value out of this JSON here. So we could change the cloud really quick. So let's just do .cloud. So set cloud is equal to test. There it goes. Okay. So anything that's in the provider config, which is defined in the APIs cluster.go, if you scroll down here, we have this new struct called control plane provider config. This is what we're actually going and interacting with because this is actually what Kubicorn is looking for. So as we start to cherry pick stuff over, we're going to have to figure out how we're going to make -- set work between this definition and the higher level cluster definition, which is defined here. Interesting. Okay, so you can come in and you can override values at runtime. So let's go ahead and apply TGIK example 2. And let's see what happens in Amazon when we do that. TGIK ex2. And I'm going to turn the verbosity all the way up because I want to demonstrate how much reconciling is actually going on behind the scenes here. The VPC does not exist. Let's see. So you can see how much it's actually checking what's there and building a map before it actually goes and tries to create everything. I think probably, if I had to guess what's happening here, the AWS API is eventually consistent, and every once in a while, maybe 1 out of every 5 or 6 Kubicorn runs for me, we hit an error, and you can just resolve that by rerunning again, and the API should kind of straighten itself out, and we will not see those eventually consistent concerns anymore. But let's look at our logs. And if you look here, it says we created a VPC. It says unable to tag new VPC. The VPC does not exist. So I bet what happened is we kind of were too fast for the Amazon API. And instead of actually trying to code in asleep, I think the proper way to handle that would be to maybe retry that once or twice. We would just have to do that for every resource and every level. So there's actually a lot of code that goes into that. And we can look at some of the code that we already have for some of this infrastructure-y stuff when we look at the different cloud providers later on. So let's try to rerun this thing again and see what happens. Okay, great. So that time it worked. So that time we created a VPC and the Amazon API came back and said, okay, you can now come and tag this VPC. So thanks, Amazon API. Tim St. Clair, retry with exponential backoff plus timeout is what we do in Kate's. And that brings up a really good point, Tim. Do we have an example of how to use the exponential backoff libraries anywhere? Because I would really like to use that in a ton of different places, both in Kubicorn and in other projects I've been working on. And I've asked around and I haven't found a good, super simple example. Okay, thanks. Tim's gonna dig it up for us. Okay, so while I was asking about that, let's go back and look through these super verbose logs and see what has been going on here. Okay, so we have our error here that's shown in red, and what's really exciting is Kubicorn is designed to be idempotent, meaning if I was to go and try to make an infrastructure mutation and something went wrong like it did here, we're gonna get this green section in our logs here that says it's gonna attempt to backtrack and clean up resources. And if you notice it went in and it's gonna delete any infrastructure it's already created, and then it's going to render that infrastructure. So the delete is actually the action against the Amazon API, and the render is actually translating that back into our original API definition. So we don't actually track the information that's relevant to Amazon. We track this abstraction layer that needs to get rendered every time we mutate against a cloud provider. So that's what this render function is doing here. We reset our timeout counter, and it says we're not going to commit our state store because we have a nil cluster spec, meaning that we're not returning anything as mutated, so it's returning as nil. So when we run it again, TGIK EX2 with full verbosity set to 4, this time it did go through, and we can see we queried to see what was actually there. We rendered again for the key pair. We did that for the VPC. We did that for an internet gateway, for security groups. We did a ton of infrastructure reasoning here right off the bat. Then it comes in and we get this informative line, which you would normally see this if you had verbosity set lower, and you wouldn't see any of this white stuff. That says it's resolving what's expected to be there. So we're now taking this abstraction layer, again, that API that we looked at in YAML on my terminal earlier, and we're actually going and trying to mutate that into what Amazon would then expect. So we're creating this like resource map of, okay, we need a key pair, we need a VPC, we need an internet gateway, we need a security group, and we're building this, this resource graph that we're gonna walk later. It's kind of similar to how Terraform does things, but if you actually go and look at Terraform, they actually build a bidirectional graph called the digraph. And the reason they do that is because they have to do this like weird permutation of all infrastructure to figure out which ones need to come first. In Kubicorn, we don't really have that same problem because we hard code, let me find the example here, all of our models. So here's the one for Amazon. And we actually go in and we say the key pair needs to be created first, then we create the VPC. Then after the VPC is created, we can create the internet gateway. The reason we have to create the internet gateway after we create the VPC is because we actually have to tell this one about this one. So we can handle this dependency management here in code, and we don't have to reason about it at runtime. So the Kubecorn code base is way simpler than the digraph stuff going on in Terraform. So we go through and we've reconciled, and the reconcile loop, if you read my book, we talk about it a little bit in there, but it actually goes and it does query what's actually there, render it, query what's expected to be there, render it in another place in memory, and compare those two together. So all a compared looks like is it marshals the object to a hash. After we have that hash, we hash the other object and we compare the two. If the two hashes are the same, we know the objects are the same and the infrastructure is as we intended it to be. We don't really care what's different yet, we just care that something's different. So on this next one, when we look at the VPC, we come in and we say, here's what's actually there and here's what's expected to be there, and notice the two are different. So what do? We create a VPC. So that's how the Kubecorn code base works. And you could see that pattern as we go through the logs. And we create internet gateways, and we create instance profiles, and we create security groups. And we finally get all the way down here to the end. And if everything worked as expected, we should get this lovely green band at the bottom. And like every time I see this green band, I'm like, oh yeah, it worked as expected. So what we have now is we have our kube config is all set up and ready to go. The name of the cluster is TGIK-EX-2, although that is not the name in the kube config, which is something we're working on in Kubeadm upstream right now, which is being able to actually call out and name the different types of clusters so that they're not just named Kubernetes. So you can now kubectl get nodes, and I can SSH into the master of my cluster by running this SSH command. And Marco, we're going to call you out here. Grills from GitHub suggested we had a Kubecorn SSH. Oh, Tim says name stuff merged today. Oh, awesome. We should take a look at that. If anybody can find a link to the PR that got merged where you can pass your name through, I would love to show it. Anyway, we now have this Kubecorn SSH command that I'm going to try and just see how it works. Wait, have we merged that one in yet? I don't even think, we might not have merged this one yet. Let's go see. I think we have. Kubecorn, I don't see it here. Let's just try and see what happens. Kubecorn SSH. Okay, so it's not in yet. But anyway, we're going to have the Kubecorn SSH command that will actually go in and connect you to your master node right out of the box. We don't have that, so we can actually just copy this and SSH into our cluster. But before we do that, let's do a quick K, which is short for kubectl. We can get nodes, and we can see that we have a master up and running, running Kubernetes version 1.10.1, which was just released. Thanks, release team. And we have one node that is schedulable. So if we want to SSH into our cluster, let's grab our cluster command, SSH -I, copy that, paste it in, yes. Okay, and I will sudo up really quick. Can you guys all see this okay? I'm gonna take that as a yes. Okay. So now that we're sudo, we can go into var log and we can see we have two cloud init files. The first one is the cloudinit.log, which this is just a bunch of Python noise, doing a bunch of crazy cloud init stuff. If something does go wrong, I'll come into this file and I'll look for like a big, ugly Python error message. I'm sure you guys have all seen those before. And that's usually gives me some idea into what went wrong or even that something went wrong to begin with. But really, if I want to see what happened with our custom bash scripts, those bootstrap scripts we looked at earlier, I'm going to look in this cloudinit output.log file. So I can paste that and we can cat that out. And this is where we start to kind of, like the rubber meets the road, we can start to glue stuff together. We run the bash scripts, the same bash scripts we looked at earlier. And here, I think right here is where the kubeadm log starts. So this is actually us using kubeadm to bring up Kubernetes control plane. And you can see it's going through all the different phases that it normally would go through. It's doing its pre-flight checks. It's generating certificates for us, both for the API server and for the kubelet. It's writing our kube config to disk, and it's getting rid of all of the trouble of having to bring up Kubernetes so that all we had to do was run this thing on a properly configured virtual machine, and poof, Docker's installed, the API server's up and running, the scheduler manager's there, the controller manager's there. And we can validate that by actually doing a Docker PS, and we can see 7 minutes ago, cluster name kubeadm. So Tim just put this in chat. I will make sure to add it to the YouTube when we're done, and we're gonna pull that up in 1 second. So here's all the Docker containers that kubeadm was able to bring up for us. So we've got, like I said earlier, we've got DNS, the API server, the controller manager. We've got our Calico pods that we scheduled, and these are all running Docker containers on our master node. So we can get out of here, and let's go to the Amazon dashboard. And we can see we've got TGIK, EX2 master, and EX2 node. And we can SSH into our node, doing Ubuntu at, yes, sudo bash, and we can cat that same var log cloudinit-output.log file. And here we can see kubeadm again being ran, and we're doing a kubeadm join with our token that we've injected thanks to Kubicorn, and it's handled all the stuff for us. Okay, so this is getting Kubernetes up and running in Amazon using Kubicorn and kubeadm, and bundling all that together into one big Go binary so that we make it easy for folks like me and you to go and get one of these clusters up and running. So now let's talk cluster API. And before we do that, I'm going to pull up this pull request so that we can take a look and see it. Yay, it got merged. I always like to see like how things get implemented in code. Oh, cool. So now you can define a cluster name, and it'll like tell you in the documentation, oh, this is great. So this is going to make it out in the next release. Rad. Good job, everybody who opened this. Good job, Karan. All right, so the cluster API work. So this is going to be a little bit of a SIG update and a little bit of a summary of my KubeCon talk and a little bit of a summary of my experiences of actually trying to vendor this thing in. And we can look at what it was like to vendor the Kubernetes cluster API into the controller when we look at the controller code that I've been working on here in a second. So first things first, let's go to the kube-deploy repository. So we started to build out the cluster API here in kube-deploy/cluster API. Joe did a TGIK on this, I think a couple of months ago, like right when I first joined Heptio. And this thing has grown tremendously, and the working group is taking off quite a bit. We have Justin Santa Barbara from Kops, we have Tim St. Clair, myself, we have Robert Bailey, Chris Rousey, a lot of people from open source, all kind of coming together, sponsored by SIG Cluster Lifecycle. And they've been able to help out from everything from creating repositories to helping us getting this thing SIG sponsorship to helping us bringing it to life. So thank you to everyone who's helped out there. And I've been really pushing this because I think it's a solid pattern. And I think the idea that using one API despite your implementation is really powerful. Right now, if we go and we look at all the different ways of creating Kubernetes, if we go and we look at kops, we go and we look at Kubicorn, we go and we look at Kubernetes Anywhere, we go and we look at Terraform, we see they all have a different user interface. Well, that kind of is like counterintuitive to the Kubernetes way of doing things, where you have one abstraction and you declare what you want, and then you have some sort of controller that comes and reconciles it. So the whole cluster API is designed to be both the API itself of infrastructure, which is defined here in package/APIs. So we can go into VN1 alpha 1, and we can actually see like this is it, like the holy grail of structs, like the cluster struct. And this is where everything starts. And we can go in and we can see the spec. So it's both the API, so defining what a user would or wouldn't care about in Go. And then we also have controllers for it as well. So here we have some common controller code that actually goes in and does like the init and the reconcile for us, the Kubernetes way of doing things. And all of it's reading the cluster API. So the cluster API working group is actually probably more of a controller working group with a little bit of cluster API sprinkled on top. So we have cluster API, the definition, and cluster API controllers, the various controllers that bring this thing to life. One of the things I wanted to bring up, I'm gonna pull up the cluster API Google Doc really quick. Let's see if I can find a link to this. I'll do it off the screen share. I don't want to show people my calendar. Cluster API, pulling up the Google Docs. Wham, kablam. So this is our notes from the SIG. Earlier this week, we had this cluster API tooling proposal, and this is exciting, particularly because we had all of the people who were involved in infrastructure kind of agreeing that this seemed like a sane approach. So I was a really big fan of this proposal. I'll put a link here, I'll drop it in chat, and I'll put it in the YouTube afterwards as well, if you guys want to come take a look. But this is telling the story of basically parody to Kubecorn. I think the original name was Cluster with a K, although we're talking about a new name now. But it talks about kind of redoing a lot of this infrastructure provisioning work as a community, which is freaking great that the community is finally taking this on and starting to think about what is the kind of the right way to solve these problems. So this tells the story of how we would bootstrap a Kubernetes cluster using the cluster API, and what it would look like to scale the cluster, and what it would look like to mutate and change the cluster, and even have debuggability and logging in the cluster, or multi-cluster management, which that's where we start walking down the cluster registry discussion path, which I think is similar in some ways, but still kind of fundamentally different from the cluster API, what we're talking about here. To me, the cluster registry is basically just like kubeconfig as a service. So anyway, if you guys get a chance, come through and check this out. I think it'll be interesting, to say the least, how this is brought to life. The other thing I wanted to mention is we have this new repository now where we're moving the stuff out of kube-deploy, if this isn't confusing enough as it is. So if I come in, we have Kubernetes, Kubernetes-sigs/cluster API. So I'll drop this in the chat as well. This is where the API definition only is moving to, and I have a feeling this new proposal is going to yield a new repository that's going to act as the implementation and the tooling that reads from the cluster API. Looking, I don't have access of this doc. So Joy Sarkar, I'm really sorry if I said that wrong. I think you can join the SIG cluster lifecycle mailing list and you should have access to the doc. And I think you can probably just request it, and I'm sure Karan will be happy to give you access to the doc. So how is this relevant to Kubicorn? We have this API that people have come together and kind of loosely agreed on as a sane way to represent infrastructure. And this happened after kops, after Kubicorn had already been created with conflicting APIs. So if you remember earlier, I talked about the provider config and how I had to munge everything into that provider config struct. And the reason for that is because I had originally written, along with the help of our many contributors, all of these API definitions here in APIs cluster. So we have cluster, and we had instance profile, we had firewalls, we had server pools, and there were all of these definitions that a user could go and configure. So these are what Kubicorn looks for and what the rest of the program expects to be there. So adopting a new API was hard, to say the least. But we were able to munge all this stuff up into the provider config, and now we get the API client code for free, and we can store these API objects as CRDs in Kubernetes. So working on getting this thing done before KubeCon, and once this first version is out and we feel like it's stable and we have some tests in place, to me, that's going to be the last feature we want to get done before we offer a stable release of Kubicorn. So how we would go about creating one of these cluster API flavored Kubernetes clusters is we would do a Kubicorn create. We would call it TGIK/EX4. We have a message from Donald Guy. As she said, y'all can join this Google group to get access. Bam, thank you, Donald. So we will do TGIK example 4, we'll call it controller. We're gonna do profile. So instead of doing AWS, we're gonna use the shorthand CAWS for controller AWS. And we should create this new profile. So the profiles in Kubicorns are, the profiles in Kubicorn are exciting because they sort of are your starting place for defining infrastructure. And we've taken a kind of serious posture here, and the fact that we kind of always want this stuff to be as literal as possible. So you will see every once in a while a function like get random token, but those are few and far between, as most of this here is just literal definition. It's strings, it's a couple of ints, and it's just a data structure. And this should be all you need to go in and declaratively create a Kubernetes cluster. In the case of the controller Ubuntu 16.04 versus the regular Ubuntu 16.04, we have a few fundamental differences. The first one is we do create our new provider config. We do create machine sets. Machine sets are similar to replica sets, but for actual machines in a cloud provider or bare metal if we ever get there. And we get all the way down here to the end, and we just set our new machine sets, and we create a new cluster, and we give it our name, and it's all this information from above. If we look at the controller version, though, we do almost the exact same thing, except for down here at the end, we actually define a Kubernetes ABS-v1 data 2 deployment. And in this deployment, we're actually pulling a Docker container that's going to serve as our controller. Now, whenever we create a Kubernetes controller cluster, the way that it's brought up is there's 2 special instances, and those are sort of like what I consider like the grandfather instances. Those are not managed by the controller, but serve as the preliminary infrastructure that allows us to run the controller to create more infrastructure. There's a couple of different ways of doing this. There's a proposal by Jessica Chen from Google that came out and said, we can maybe just do a very lightweight API server style of doing this. We already had a lot of this code in place to create virtual machines. So I just said, hey, let's just create a small Kubernetes cluster. And after that small cluster is up and running, we can then use a controller to scale it as large or as small as we want, but we'll never be able to go smaller than the 2-node minimum today. And I would love to get feedback on what folks think about that. And we'll actually bring that to life and see what it looks like. So the first thing we want to do is we want to apply our newly created controller profile. Kubicorn apply TGIK EX4-controller. Again, we'll do verbosity all the way up, and we'll do that to 4. Let's see what happened here. Unable to create new VPC. The dreaded case of the eventually consistent Amazon API strikes again. Oh, the maximum number of VPCs has been created. Let's see what we did here. So I can delete this one because we're no longer using it. And I think these were the ones that were created earlier that were eventually consistent that we did not take ownership of. Which actually, this is a really great example of one of the problems that we brought up in open source last week, but it's still a problem. And there's not really a good way of dealing with it, which is in this case, let's find it in our logs. Here, unable to create new VPC, the maximum number of VPCs has been reached is a symptom of wherever we tried to create it earlier, higher up in the logs, where we created it, the Amazon API gave us 200 and said, yes, we've created it. And then we tried to query for it, and we actually got a 400 saying that it's not there yet. So there's this weird delta. If we did implement the back-off logic like Tim suggested, we would have at least be able to retry this request and alleviate this bug. But in some cases, you could create infrastructure, your code could move on, assuming that it's been created, and then you hit a bug downstream. And when you hit that bug, your code actually takes a different path out of itself where it doesn't take ownership of that infrastructure it thought it created, but then couldn't look up later. So there's this chance that you're going to orphan infrastructure in the cloud. So this is like one of the many really, really annoying problems infrastructure engineers get to deal with. So hopefully we're going to try to make this as seamless as possible as we sort of iterate on this tooling here. So let's see, that one has instances. We want this controller up and running. Actually, I think we can delete this one. Well, we should have enough anyway. So let's try this one really quick. I've got 3 clusters up and running, so we might have to nuke one of these things. Okay, Kubecorn apply, TGIK EX controller minus v4. Okay, good. We made it past the initial VPC. So again, it's kind of doing the same thing it did before, except for this time we're just creating a very small cluster with 2 nodes. We can go into Amazon and we can see our cluster coming to life, probably most exciting in the EC2 view here. And we can filter on running. Beautiful. So we should see, not test controller, because this is something I was working on earlier, but we should see TGIK EX4 controller come to life here in the next few seconds. So what we're doing now is we're attempting to look up the master IP. So this is an example of a place where we've hard-coded like our own retry logic. And if we can get this thing pulled into like a more standardized library, it would be helpful. But what we're doing here is we're waiting for the master instance to come up so that we can query for its master IP from the Amazon API. And that's what happened here is we, wow, how fast did this thing go? Here. We tried and tried and tried, and eventually we were able to get it. We found it. It's right here. We then moved on with the rest of the provisioning steps here. What's happening down here at the end, it says waiting for Kubernetes to come up. File does not exist. What's happening right now is Kubeadm is silently chugging away in the background on each of these virtual machines, bootstrapping Kubernetes for us. Once Kubernetes comes up and bootadmin releases back to stack, we're then going to do the very last thing in the bootstrap file we looked at earlier, which is copying our kubeconfig to home, which is how we know the kubeadmin has exited and that we can expect to find the kubeconfig file there. So as soon as kubeadmin gets done on the nodes, we're going to get our kubeconfig, and we're going to look and see what is different about this deployment of Kubernetes versus the one we did earlier. And I'm going to do a quick time check. So we started at 1:30. It's been an hour and 10 minutes. So I think what we'll do is we'll look at the controller stuff here. We'll take a look at what it created, and then we can try to get the controller up and running in the last 10 minutes or so if we have time. Because I don't want to be taking up too much time since we got a late start today. Okay, so we wrote our kubeconfig and we echoed out our cluster API. We have logs turned up all the way, and we declared our cluster TGIK EX4 controller. Down here at the end, this is what's really exciting is we declared these machines. and it said cluster API has applied successfully. So now if we do kget nodes, okay, nodes are coming up, so that is good. But more importantly, we can now do kget machines, and this is exciting. So the original 2 machines we created with Kubicorn are listed here. Notice they do not have an ordinal number next to them. It's just a master and node. And the way that this is currently designed is this master and this node will be here for the duration of the cluster's lifecycle. Now, every time you do see a node dash number, this is the machine that is intended to be managed by the controller that is already in place. So I started hacking on a controller. It does not work, but it's really close. And that should be, I don't think it's going to be deployed yet because I haven't pushed my Docker container, but we can actually pull the logs and see what's going on here. Caslin Field says, took me a bit, but I found Kubicorn t-shirts on the Women Who Go site available in men's, women's, and kids cuts. Marco asked, Kris, did you use the Amazon controller profile? I certainly did. So let's take a look at the pod that is running from the Kubicorn controller deployment. So we can kget po, no resources found. That's because it's running in the Kubicorn namespace. And we can actually see our pod here. And I think all this thing is going to do is just run an infinite loop and not actually take any action. So what we can do is we can do Kubicorn, or I'm sorry, k logs name of our pod / namespace Kubicorn, starting an infinite loop, and it's just going to hang here and do nothing. So the pod is just hanging and not taking any action. So what we have here is we have the Kubicorn code base. I want the controller code base. So we have this whole other project that we're calling the Kubernetes or the Kubicorn controller. And that can be found here in Kubicorn / controller. Now this is a cluster API controller starting point. One of the things that we've talked about, and we've talked about this in upstream, and I would also like to see it here. And if upstream does continue and we do start to build tooling in upstream, I have a feeling some of this code may or may not get recycled, but this code and possibly even the entire Kubicorn project could fall subject to this broader upstream effort. That's certainly where I would like to be putting my time, is into the group effort upstream. So here we have this package called, actually let's not look here, let's look here. So here we have this package called service, I renamed it. And in here we have one cloud provider called AWS, and we have this instance.go, which is what we're looking at here. Instance.go is an implementation of this interface, which is super simple. It's basically CRUD for a machine. It's got create, it's got exists, it's got destroy, and it's got list IDs. If you go and you look in the kube-deploy code base, you will see that they have actually done a similar pattern, but they're calling these machine actuators. So to use the common code in kube-deploy, you would want to come in and use one of these machine actuators, which the common code is defined here. But again, it's a very similar interface. It's got create, it's got delete, it's got update, and it's got exists. Because that's really all we need to do to manage one of these Kubernetes nodes to bring it up. Now, the trick is to bringing up one of these nodes is you are going to have to inject some sort of user data. So that's going to be the cloud init data, similar to the bootstrap scripts we looked at earlier. The way that Kubicorn does that now is it's actually storing that user data in these CRDs, which includes the token. So that's kind of a hacky move to get this thing up and running for the sake of a demonstration. Please don't run this in production anytime soon. But here we're starting to really take advantage of the full scope of Kubernetes, because we start to inherit things like, oh, we're running as a CRD, so we can start to store this stuff as secrets, and we can start to use the rest of the Kubernetes fundamentals to actually help us out here to bring this controller to life, which is something I really want to see in upstream. So we can run the controller kind of wherever we want, if you think about it, because its only job is to read from these CRDs and then go and take action against our cloud provider. And as long as whatever is reading from these CRDs, one has access to read them and two has authentication information with the cloud provider, we could theoretically run this controller on our laptop. We could run it on a Raspberry Pi in the closet. We could run it in cluster. We could even run it in a different Kubernetes cluster if we wanted to. In this case, we're going to run it locally on my computer, see if we can't get it working, stop it, delete some nodes, and then deploy that to Kubernetes and see if we can't get the controller to reconcile nodes for us in Kubernetes. And I'm probably going to give this about 5 minutes of hacking and see how folks are doing and see if we want to wrap things up because of time. So here in the controller repository, I can go up a directory and move into controller. Again, I want to run make all to compile my code. And then the binary will be called Kubecorn controller. We want to tell it profile AWS, and we might as well turn our verbosity all the way up to 4. Here is an interesting point. So in this example, we're actually passing in -p AWS, which tells us the cloud provider to use, which would then switch and tell us which of the AWS directories to use here. One of the big problems with that is, one, if you wanted to implement your own cloud provider, it's a code change. And two, if you wanted to change your cloud provider at runtime, it's a switch in code, which means you have to actually change the command line flags. So a pattern that I've been kind of thinking about, and I'll probably write a proposal for this, but I'll just share it here so you guys can hear it, is using gRPC as the interface between two containers running as a sidecar in the same pod. And one of the containers would be the common code for the Kubecorn controller, or open source, you know, if we call it cluster, we call it crag, or we call it cuddle, I think was one of the other name proposals, controller. And the other one would be the cloud provider implementation, and they would communicate over a gRPC interface that I have a feeling would look a little something like this, and also a little something like this here. And so then we could just call out to that and say, you know, create a machine, delete a machine, whatever. So coming in here, we compile our code and we run our controller. And I think we're probably going to get a few errors on we're missing some values or they're invalid requests to Amazon, and we're going to see if we can fix those. So this actually takes a little bit longer than Kubecorn to compile because it's vending so much of the Kubernetes code bases. It's got API machinery, it's got client Go, it's got a bunch of other stuff. And then we're going to try to run it and see what happens. Unknown flag, p.aws. Oh yeah, I have that as an environmental variable already. I pulled that p.aws out of there because I didn't like it. So I am going to recompile it again just so that I don't have to re-enter my command, but you could just rerun the binary and it should have worked fine. Okay, cool. Great, so we got a panic. So time to start hacking on our controller. So the first thing we did is we started our control loop, and it looks like we tried to create a machine and something was set to nil, and it said unable to create machine, test controller 1 master, unable to create instance, missing parameter, the request must contain image ID. So we can look and see what we're getting out of the CRD, which should, this is where we're setting our image, and we're pulling it out of the CRD to see if we're getting this thing right. And look, I already was debugging on this, so I'm already debugging the server pool image. So just to hack this, I'm gonna do if, actually, hold on, what was the name of this one? Test controller 1.node. So these are the special case master and nodes that we don't want to be configuring anyway. So why are we calling create on those? So if we go up a level to the machine.go, we can see that we're probably seeing if it exists, and if it doesn't exist, try to create it. So I bet if we came into create.go, and just for now, just to get the code running, if we did if pc server pool.image is equal to empty string, I don't know why I put parens around that. I bet we can return empty string and no error. Let's see what happens. Cool. So as I'm getting this up and running, does anybody have any questions on the cluster API or Kubicorn or the future of Kubicorn or the work that's going to be starting in upstream, hopefully, or anything on that matter? Panic error, runtime index out of range. And that is on AWS instance.go on line 113. So here we are, again, being bad gophers. Let's put a to-do in. And we can do a quick lane check on that. Is less than 1. We can bail out. See what that does. And rerun it. Cool, runtime index error out of range. Okay, well, I'm gonna keep hacking on this. Hopefully we'll have a PR out by the end of the day, and you can join us for a live demo in the coming weeks in the Cluster API working group, which, let's take a quick look here. It is Kubernetes SIG cluster lifecycle mailing list. And then I think in here we can find the working groups. Yeah. So you can join the SIG cluster lifecycle mailing list, and you'll get an invite to Wednesdays at 10 a.m. Pacific, and you can get our meeting notes and agenda, and you can see a list of all the recordings. And we should be able to do a quick demo on this controller. Moving forward, I don't want to eat up too many people's time with me hacking on nil values and empty map sets. So if anybody has any questions, feel free to answer now, or to ask now, and I'll try to do my best to answer. And if not, we will see you guys next week. Going once for questions. Thanks, you're welcome, Noah. Thanks for saying thanks. Thanks, Carlton. Bye, Justin. Awesome. Well, we will see everybody next week. Have a good weekend. I'm gonna stay logged in so I can grab any more comments as they come trickling through. And then I get to go and update the YouTube documentation for our stuff internally and publish this to the YouTube channel as the recording for the week. Brad, thanks for a good time, everyone.